Hello and welcome to Unit 2, Lecture 5 for Introduction to Logic. We're working our way through derivations still. Today we're going to learn some new rules. Talk a little bit about why we want these new rules. So we don't actually need them. It turns out that using the first rules that you learned along with indirect derivation and conditional derivation, you can demonstrate the validity of any argument in sentential logic that's valid. You can do a derivation for, but some of them are really complicated, like this problem here, Q arrow P, not Q arrow R, show P or R. If you do it just using the rules that we learned so far, you have to do it this really complicated way. I'm not going to bother going through this, but you end up doing an indirect derivation within an indirect derivation, and that's pretty complicated, and I don't want you to have to do things that way. So to make our lives easier, we're going to introduce some new rules. These are rules for dealing with negations of complex statements. If you get a negation of a complex statement, what can you do with it? Using the rules we've learned so far, the only thing you could do with it is get a contradiction with it with indirect derivation. But it's better to actually have a rule that transforms that negation of something complex into something else. So we have 4 rules like that: not ampersand out, not wedge out, not double arrow out, and not arrow out. These are rules for dealing with negations of statements. So if a negation of an and statement, if it's not true that both A and B, from that you get it that if they're not both true, the first one's true, the second one has to be false. So not, in parentheses, A and B turns into A arrow, not B. If you get a negation of an or statement, not A or B, that means neither side is true. So from that you can get that A is false and you get that B is false. You can do both of these and get both A is false and B is false. Not A or B turns into not A on one line, not B on another line. Not double arrow outs. Remember, a double arrow statement is true when the two sides are the same. So if it's false, that means they're different. If they're different, then not A will be the same as B. Not A if and only if B. So all this does is removes the parentheses. You have negation of A if and only if B. You get not A. Here the not's only applied to the A if and only if B. And finally, if we have negation of an arrow statement, not A arrow C, remember arrow statements are only false when the if part's true and the then part's false. So from that you get that the if part's true and the then part's false. So if A arrow C is false, then A is true and C is false. Notice that when you do not arrow out, the arrow changes to an ampersand. When you do not ampersand out, the ampersand changes to an arrow. Make sure you change them when you do them. So let's do some problems that use these rules. Q arrow P, if not Q then R, show P or R. We'll do this by indirect derivation. Assume the negation of the entire or statement. Show a contradiction. Now, there's nothing we can do with line 1 and line 2 the way they are because they're arrow statements. When you do arrow out, you need to have either the if part or negation of the then part. You have Q or not P for line 1, for example. We don't have either of those. So nothing we can do yet with line 1 and line 2. What can we do with line 4? We can use our new rule for negations of or statements. So 4 is an or statement, it's a negation of 1. When an or statement's false, both halves are false. So line 4, not wedge out, gives us not P and gives us not R. 4, not wedge out. Now I have what I need to use line 1. I can do both colons on line 1. If Q, then P, but not P, I get not Q. From 1 and 6, arrow out. And from line 2 now, if not Q, then R, I get R. From 8 and 2, arrow out. Now the R and the not R contradict each other, so I get splat. I get my contradiction between 7 and 9. So I've shown splat, therefore I've shown this by indirect derivation. Let's do another one. So we're trying to show if B, then C. Whenever we're trying to show a conditional, I'll recommend you do it by conditional derivation. Assume that B is true. Use show line to show that C is true. Now, how do I want to show C is true? I'm going to show C by indirect derivation. Assume C is false. Try to get a contradiction. So the not C at 5 is the negation of the then part of 1. So I get the negation of the if part, not if not A, then B. So 1 and 5 modus colon gives us the negation of the if part of 1. Now we have a negation of an if-then. If an if-then is false, that means the if part's true. We don't change the if part. Negation moves over to the then part, and the arrow changes to an ampersand. So that's 7, not arrow out, but not A and not B. From that I get not B, an ampersand out. Now I have a contradiction between the B and the not B from 3 and 9. I've shown this by direct derivation, therefore I've shown this by indirect derivation, therefore I've shown this by conditional derivation. Okay, let's do one more. If P, if and only if Q, then M, either M or P, not both not M and not Q, show that M is true. We'll do this by indirect derivation. Assume not M. Do show line to show splat. That's how indirect derivation works. You assume the opposite of what you're trying to prove, then you show line to show splat. So we get not P if and only if Q, modus tollens on 1 and 5. So if P if and only if Q, then M. We also get P from line 2 and 5, wedge out, either M or P, but not P. What happens to line 3? It's a negation of an and statement. If the first part's true, then the then part is the second part is false. So this negation on the beginning of 3 moves over and joins on to this, so we end up with a double negation, and the ampersand changes to an arrow. That's 3, not ampersand out. Then line 5 and line 9 will give us not Q. By modus ponens. And drop off that double negative on 10. Now what can I do with line 7? I haven't used line 7 yet. It's negation of an if and only if. The if and only if, all that happens is the parentheses get removed, negation goes on to the first half of the if and only if. So 7, not double arrow out, we'll change that into that. And from 12, we can change that two-way arrow to a one-way arrow in either direction. Now I want Q arrow, not P, because I have Q. And if I could get not P, I have a contradiction with line 8. So 12, double arrow out. If Q, then not P, so I get not P. From 11 and 13, arrow out. Now splat, 8 and 14 contradict each other. So I've shown that, therefore I've shown that by indirect derivation. Oh, 8 and 14. All right. So often I get asked, how do you know what kind of derivation to do for what kind of problem? What's the best way to go about it? Should I do conditional derivation, indirect derivation, some combination of them? So I want to give you a chart of my advice of what to do for any kind of problem. If you can see far enough ahead in the problem to see how to do it a different way, never mind this chart. But if you need something to fall back on, it's good to memorize this chart of what kind of derivation to do for what kind of problem. It has to do with the show line. You don't have to look at the premises, just look at the show line. The show line will tell you what kind of derivation to do. Now, there are 7 different kinds of show lines. I have a chart here for the first 5, just telling you what kind of derivation to do. We try to show a single letter by itself, an atomic statement. Do it by indirect derivation. Assume the negation of the atomic statement and try to show splat. We try to show negation. No matter what it's negation of, it could be negation of something complex. Do it by indirect derivation. Assume the thing without the negation, try to get a contradiction. We try to show an or statement. Again, indirect derivation. Assume the negation of the entire or statement and try to get a contradiction. If you try to show an arrow statement, however, I recommend doing it by conditional derivation. You'll assume the if part and try to show the then part. you're trying to show a splat, trying to show a contradiction, it usually happens when you're already doing an indirect derivation. The splat itself, that show line, you show by direct derivation. Then there's no new assumption or new show line. You just start working on using the rules to get that contradiction. Now that's 5 of the 7 possibilities. There are 2 possibilities left. One is when you're doing a two-way arrow statement. I recommend you break that up into 2 problems. You'll write direct derivation by that show line, and immediately underneath it, you'll write the show line to show BFN going one way, and when you're done with that, you'll show BFN going the other way, and put them together with double arrow in at the end. We did some of those the class before last. Trying to show an AND statement, I recommend doing 2 indirect derivations. First, you show the first part of the AND statement by indirect derivation. Then you show the second part of the indirect derivation, but second part of the AND statement by indirect derivation. And you put them together by ampersand in at the end. We'll do a problem like that in a second. We've already done some of those, but we'll do another one in a second. So this chart gives you my strategies for what kind of problem to do for what kind of thing. Now, oftentimes when you set this up, especially when you're doing a conditional derivation, you'll get a new show line. You want to go back to the chart for the new show line and figure out what to do for that new show line. Keep going until you get show splat, and then you do an indirect derivation. So if you follow the chart, you'll always end up doing an indirect derivation. Let's see how that works for this problem. So the advice when you're trying to show an AND statement, you can ignore the premises. Just look at the show line. The show line for an AND statement is just you write direct derivation by this show line, but then you put in a new show line to show the first part of the AND statement. And you do that by indirect derivations. We're going to do 2 indirect derivations, one to show P, one to show not R. We're going to assume not P. Try to show a contradiction. So now I can use line 5 along with the premises line 1 and 2 to try to get a contradiction. So I can do most tolins on line 1. I get not P or Q. The negation of the if part from 1 and 5, arrow out. And that's a negation of an OR statement. I can use one of my new negation rules. It gives me the negation of each of the 2 halves. So I get the negation of that. I don't need not Q, so I'm just going to take the negation of not P. 7 not wedge out gives me the negation of any of the 2 sides of the OR statement. Now I have a contradiction between 5 and 8. I've shown this and I've shown this. The idea behind showing an AND statement is I'm going to show each of the 2 halves. So I'm going to put in a new show line to show the other half of the AND statement. Show not R. Do another indirect derivation. Assume R. Show a contradiction. Now I want to use line 2. If R and P, then not R. I can't use anything that's inside this box from 5 to 9, because once you draw a box around something, it's gone. But I can use line 4. The word show is crossed off. So I get R and P together by putting 4 and 11 together. That gives me the if part of 2. So then by the if part of 2, I get not R. 2 and 13 arrow out. Now I have a contradiction between 11 and 14. So I've shown this and I've shown this. So the last step when you're trying to show an AND statement, if you've shown each of the 2 halves by indirect derivation, you need one last line where you put the 2 halves together by ampersand in. And I'm using line 4 and line 10, the 2 show lines that are crossed off I can use now. Not spot in, it's ampersand in. I've shown this by ampersand in. There we go. Okay, let's do another one where we're following the chart. When you follow the chart, you just look at the show line. That'll tell you what kind of derivation to do. If you're trying to show an OR statement, the advice is to do it by indirect derivation. Assume the negation of the whole OR statement. New show line to show splat. You show splat, that's a new show line. You always show splat by direct derivation. That's when you start applying the rules. Nothing I can do with lines 1 and 2. I would need A or not B or not C or not D to do something with 1 or 2 or 3. I would need something else. But line 5, I can apply the negation rule right away. I get each of the two halves being false. So I get not C and 5 not wedge out. I get not A. I get the second half false. 5 not wedge out. Yeah, you get a double negation when you're applying not wedge out to something that has a negation on it. I can drop off those double negatives on 8. And I have what I need to use line 1. So I get B. Okay, then B I have A. 1 and 9 give me B. Not C, then D. So I get D. 2 and 7. Now to use line 3, I need a negation of one of the two sides of 3. I don't have a negation of one of the two sides of 3, but I do have the unnegated version. So if I double negate 10, for example, I get not B. I have what I need to do wedge out on 3. So I get not D. Either not B or not D, but I have not B. So 3 and 12 wedge out gives me D. Now I have my contradiction between 11 and 13. Shown that, therefore I've shown that. All right? There's one more problem here. We try to show a two-way arrow statement. I'm trying to keep these recorded lectures short. I'm not going to bother doing this one because this is a really long problem. I'll show you the answer. But the key when you're trying to show a two-way arrow statement is to do two conditional derivations. One to show the if-then going this way. When you're done with that, you'll show the if-then going the other way. And again, it's a really long problem. And then you put the two together by double arrow in when you're done with that. That's how you show a two-way arrow statement. We did some of those when we were doing conditional derivations. Do two conditional derivations to show a two-way arrow statement. I'll do another one during my review session, time after this, not next time, but time after. I'll do another example like that, so you'll see it in action again. All right, that's it for today.